Deep in the heart of Chile, a revolution is brewing. High atop a mountain called Cerro Pachon, a new eye on the universe is preparing to open. This is the Vera Rubin Observatory, a groundbreaking facility poised to change our understanding of the cosmos forever. It is not just another telescope, but a marvel of modern engineering and ambition. Its mission is to capture the sky in unprecedented detail, creating a cinematic view of the universe in motion. For centuries, we have looked at the stars and seen a static, unchanging canvas. The Rubin Observatory will shatter that illusion, revealing a dynamic and ever-changing cosmic dance on a scale we have never witnessed before. This is more than an upgrade. It is a fundamental shift in how we observe and interpret the heavens. Instead of looking at small patches of the sky, it will survey the entire visible southern sky, over and over again. The observatory bears the name of a true giant of astronomy, Vera Rubin. This is a fitting tribute to a scientist whose work fundamentally changed our view of the cosmos. In the 1970s, Vera Rubin and her colleague Kent Ford made a startling discovery. They were studying the rotation of spiral galaxies, expecting to see stars at the outer edges moving more slowly than those near the center. This is what Newton's laws of gravity would predict. After all, the planets in our solar system follow this rule, with distant Neptune orbiting the Sun far more slowly than nearby Mercury. But that is not what they found. Instead, they observed that the stars on the outskirts of galaxies were moving just as fast as those in the middle. Rubin's meticulous measurements provided some of the most direct and compelling evidence for the existence of something invisible, something mysterious that was providing the extra gravity. This unseen substance, which we now call dark matter, appeared to make up the vast majority of matter in the universe. Her discovery laid the foundation for modern cosmology, establishing the dark matter problem as one of the most pressing questions in physics. The Vera Rubin Observatory is designed to tackle some of the biggest and most fundamental questions in science. Its primary mission, the Legacy Survey of Space and Time, LSST, will provide an unprecedented data set for exploring the darkest corners of our universe. One of its key goals is to shed light on the enigmatic nature of dark energy. This mysterious force is believed to be responsible for the accelerating expansion of the universe, a discovery that earned the 2011 Nobel Prize in Physics. By precisely measuring the distances and distribution of billions of galaxies, the Rubin Observatory will help cosmologists trace the history of cosmic expansion with unparalleled accuracy, providing crucial clues about the force driving it. At the very core of the Vera Rubin Observatory's power is its remarkable telescope, a masterpiece of optical engineering. It is a specially designed instrument known as a Simony Survey Telescope, named in honor of its generous private benefactors. The LSST camera is the largest digital camera ever constructed for astronomy, a true giant in every sense of the word. It's roughly the size of a small car and weighs nearly 3 tons, a behemoth of technology designed for a singular purpose, to capture the universe in breathtaking detail. This field of view is enormous, covering an area of the sky about 40 times the size of the full moon. This is the key to the observatory's ability to survey the entire sky so quickly and efficiently. The Vera Rubin Observatory is more than just a telescope and a camera. It's a data-producing factory on an industrial scale. Every single night it operates, the observatory will collect around 20 terabytes of data. Within 60 seconds of an image being taken, sophisticated software will compare it to a deep reference image of the same patch of sky. Any object that has appeared, disappeared, moved, or changed in brightness will trigger an alert. The observatory is expected to issue about 10 million of these alerts every single night, heralding a new era of real-time astronomy. This vast archive of data will not be kept locked away for a select few. In a move that truly democratizes astronomy, the data from the Rubin Observatory will be made available to the public and the entire scientific community with no proprietary period. The Rubin Observatory's LSST is about to usher in a golden age for what astronomers call time-domain astronomy. That is, the study of a universe that's always in flux. The cosmos is actually a wildly dynamic and honestly sometimes violent place, packed with things that flicker, flare, and explode. One of the most dramatic sights Rubin will capture is the supernova, the explosive death of a star. The LSST is expected to find thousands of these every single year, which is just mind-blowing. It'll witness tidal disruption events, where a star strays too close to a supermassive black hole and gets ripped apart by its gravity. And it'll play a key role in what's called multi-messenger astronomy. While a lot of the Vera Rubin Observatory's focus is out on the distant universe, it's also going to sweep through our own cosmic backyard, and that has some big implications for us right here on Earth. The legacy survey of space and time will be the most thorough and complete census of our solar system ever attempted. A key part of this mission is planetary defense. Among all those millions of rocks orbiting the Sun, there's a special class called Near-Earth Objects, or NEOs. These are asteroids and comets whose orbits bring them close to Earth, and well, some of them could pose a real impact hazard. By tracking these objects night after night, year after year, the LSST will pin down their orbits with amazing precision. A clear early warning, maybe decades ahead, would give us the chance to develop and launch missions to deflect a threatening asteroid, turning what could be a global catastrophe into just another natural disaster we managed to avoid. The Vera Rubin Observatory is set to revolutionize another key area of astronomy, the hunt for planets orbiting other stars, known as exoplanets. Rubin will employ a different complementary technique called gravitational microlensing. Microlensing can also detect so-called free-floating or rogue planets that have been ejected from their home systems and now wander the galaxy alone. Rubin's survey of the dense star fields towards the center of our Milky Way will be the most powerful search ever conducted for these lonely worlds. One of the most exciting and honestly surprising discoveries in recent astronomy has been the detection of visitors from other star systems passing through our own. The LSST will discover dozens, maybe even hundreds, of interstellar objects during its 10-year mission. Perhaps the most exciting prospect of the Vera Rubin Observatory is not what we expect to find, but what we cannot even imagine. Throughout the history of science, the greatest leaps in understanding have often come not from confirming existing theories, but from discovering something completely unexpected. The Rubin Observatory, with its unprecedented survey capabilities, is designed to be a discovery machine for the completely unknown. It is, hands down, our greatest tool yet for finding the unknown unknowns. What could these discoveries be? We can only speculate. Perhaps the observatory will find a new type of stellar explosion, powered by physics we do not yet understand. It might detect the faint optical flashes from the annihilation of dark matter particles in the center of our galaxy. As we stand on the cusp of its first light, the Vera Rubin Observatory represents more than just a new telescope. It signifies a profound transformation in our relationship with the cosmos. It will present us with a universe in constant, vibrant motion. This future is not confined to the professional astronomical community. By making its entire dataset available to the public, it invites everyone to participate in the journey of discovery. Students, teachers, and citizen scientists from all corners of the globe will have the tools to explore the universe and make their own contributions. Ultimately, the Vera Rubin Observatory changes everything because it changes our perspective. It forces us to see the universe not as a collection of distant, isolated objects, but as a dynamic, interconnected ecosystem, constantly evolving and full of surprises. The dawn of the Vera Rubin Observatory's operations marks a pivotal moment for science and for humanity. It represents what we can achieve when we work together to ask the biggest questions. As it prepares to open its eye on the sky, we are not just anticipating new data, we are anticipating a new understanding of our place in the cosmos, a new vision of the universe that is richer, more complex, and more alive than we ever imagined. The cosmic movie is about to begin, and it promises to be a spectacular show. The future of astronomy is not just coming, it is already here.